we're talking about twirling this ball on the string, okay? And so the string was 2.3 feet, and so I decided that if, so I kind of made up this question, and I said, suppose that from the starting point, the ball, so consider the ball traveling its first 8 feet around the arc. Traveling its first 8 feet around the arc. So that's a guess at where it might be. It's going to go its first 8 feet around the arc. So my question is, can you express, without using your calculator, can you write an expression for the location of the ball at this moment? So right now, can you express where the ball is at this moment? So before we start, we better know, where did it start? So how about what coordinates, if it starts at the 3 o'clock position, what are the coordinates of where the ball started? Okay, 1, 0. Is that possible? 1, 0. And what would the 1 represent? Because I thought the string was 2.3 feet long. We could have coordinates in terms of radius lengths. That'd be perfectly legitimate. It would start at 1 radius length to the right, 0. But I want to do this in feet. So I want these coordinates to be in feet. So what's the starting point of the ball? 2.30. So given that point, 2.30, I want you to express, no calculator, express the coordinates of the point if it has gone the first 8 feet around the circle. This is review. So have you learned something here in the last couple weeks? Have you learned something? This is review. So it's gone 8 feet. Where's the ball? Go. Where's the ball? No calculator. Okay, Angelica. All right, so did you make any progress with this?
I got 2.1 and 0.8.
But are you making estimates, or so we want expressions that give exact results?
Yeah, I was thinking.
What's that? All right, so how can we get started at expressions here that give us the exact location of the ball? Okay, so let me stop. Can I just stop you right there? So you're talking about cosine. What is cosine in general? So in terms of these two coordinates, what does cosine have to do with it? All right, so if we're going to get x and y coordinates on a circle, we're going to use, first of all, for x, we're going to use cosine. So he's talking about cosine. So cosine of what? What goes into cosine? So many of you, the rest of you have your quiz today. What was that? Yeah.
The radius swept counterclockwise from the top position.
The radius, what swept counterclockwise? Angle swept counterclockwise from the 3 o'clock position. How are we going to get that angle? And how'd you get that, Gage? What's that mean?
That's the radians divided by radius length. Gives us the theta, which is the angle swept counterclockwise from the theta.
So how does that give radians? If we take the length of the arc and divide by the radius, what is that?
How many radius lengths around the circle is around?
That's right. And the number of radius lengths around the circle is the same as? Number of radius lengths around the circle equals? Angle in radians. So really that calculation makes more sense as a number of radius lengths. We're taking the whole arc and we're dividing it up into chunks of 2.3. And so we're going to get how many chunks of 2.3, or how many times you're splitting up A into 2. How many times you're splitting up A into lengths of 2.3? That's the number of radius lengths, and we know that value is the same as the angle of radians, and that's our input into cosine. Swept from counterclockwise from 3 o'clock. All right, does this give us, so back to Angelica, does that give us the x-coordinate? Okay, what about just that? What does that give us? Good. It gives a number of radius lengths, or the percentage of a radius length that we are. And so then to get it in feet, we're going to take that percentage or that fraction of the radius 2.3. So then, of course, now that we wrote down the first one, you can all get this easily. Same angle, but the vertical distance will be, or the y-coordinate will be sine. Okay, let's get now calculator and see if our answers make sense. So if I remember, is it negative 2.17? Someone get that? And negative 0. As soon as you get it, tell me. Negative 2.17, did you get that? As soon as you get it, shout it out. 7.6. Do these numbers make sense? Are they numbers of feet or radius lengths? Is it feet or radius lengths? Feet, right? It could possibly be radius lengths if it's greater than 1. So, and how many radius lengths for the x-coordinate here? No, how many radius lengths for the x-coordinate? Oh, I'm sorry. How many feet? Did I say radius lengths? I meant feet. How many feet? Negative 2.3. So we look at this value and we say we got negative 2.17. Seem about right? Yeah, almost there, right? Almost to the far left. And then less than a foot down. Less than a foot down from the horizontal diameter. So these numbers make sense. Okay? Review, right? Review, and maybe definitely one of the most important things in the whole module is this is about understanding what sine and cosine are. And so what's the input? The angle swept counterclockwise from the 3 o'clock position. What's the output? Vertical distance and horizontal distance from the diameters in radius lengths. So if you want it in the units of the radius, you just multiply it by your radius length. And it takes that fraction of your radius length. Questions on that review? Okay, so then we had okay, so we know that just for the cosine, the input is this angle, this very specific angle we've talked about. But then last time we said that we had this. So now rather than a function of theta, the angle, we have a function of t. And so now the input is t. And we said that this expression that we're taking the cosine of, or that's going into cosine, we have a special name for that called the argument. So that expression can be long and complicated, or it can be short and sweet like this one. But in any case, whatever you're putting into the cosine is the argument of cosine. So, what quantity does the argument represent? What quantity does the argument represent? Is it time? Is it distance? Is it angle? What is it? Jonathan, what's that? Why is it angle?
Because 9.7 times time is equal to theta.
Okay, that's true. So that's because it's equal to theta. But in the context here, why does it have to be angle in the context?
Because the input for cosine is the angle swept through theta.
Right. The argument is that thing we're putting into cosine, and we're pounding it into our head that the input into cosine is the angle swept counterclockwise from the 3 o'clock position. Okay? So because it's going into cosine, that argument is the angle swept counterclockwise from the 3 o'clock on the circle. Okay, what about the period? So what is the period? Is the period talking about a amount of input or an amount of output? The period is an amount of input or an amount of output? Ooh, I stumped you there. Jonathan.
The amount required to get one full cycle.
He says that the amount of input required to get one full cycle of output. That's what it is. The period is an interval of input. So in this case, t. It's going to be an amount of time that results in a full cycle. And so in order to get that, all we have to know is cosine. What's the period of cosine? Or what's the angle? What's the interval of angle that makes cosine go through one full cycle? 2 pi. So then we want the value of t such that our angle goes through 2 pi. That's how we reason about it. We know that that argument has to go through an interval of 2 pi. So we take the argument and we say we want to know what value of t is going to make that argument reach 2 pi. So then we solve for t. So when t gets to 2 pi over 9.7, this thing will reach 2 pi and we'll have a full cycle. You see? So we find the period by knowing that the period of cosine is 2 pi. Okay, any questions about that? Let's review from last time. Okay, so let's look at while I take roll. You got something to work on here. I'll make this bigger. So we got a Ferris wheel. And the associated units are meters and minutes. Okay, the associated units are meters and minutes. And a function related to this Ferris wheel is f of t is 28 cosine 3t. So we're going to break that up into every possible expression that you could talk about there. And you're going to analyze, what does t mean? What is 3t? What's the meaning of that? What's the meaning of 3? Cosine of 3t, 28 cosine 3t. And then, so make sure you have a full and specific definition of each of those expressions, what they mean, what value they give you in the context. And then, what's the input, what's the output, what's the argument, what's the period. So you got lots of work there, and I showed you the graph down here. I'm going to try to make this even bigger. And then here's the graph of that function. So we're interpreting what everything means in that function rule. Okay? Is the task clear? Gauge t. What does t mean?
T is the time input in minutes.
Okay, time in minutes. Which time in minutes? So if it's a changing quantity, it's always since something defines when we're starting the time.
Since starting the rotation of Ferris
Okay? All right, that's true? Mm-hmm. So, oh, shoot. Something like that. So time in minutes since leaving, where? 3 o'clock position. Okay. Good. So 3t. What quantity is 3t? Ryan, in the back. What would 3t represent? What's that? Well, where is it in the equation? Look where it is in the equation. This is on your. Do you have recitation today or Wednesday? Today. So you ready for your quiz? Where is 3t in that equation? What does it represent? Nope. Taylor.
It represents the angle swept from the 3 o'clock position.
Angle swept counterclockwise from 3 o'clock. Why? Because it's going into cosine. It's the thing that's going into cosine. So it's the angle swept counterclockwise from 3 o'clock. It's the input. Okay, so then what's the 3? If t is the number of minutes and 3t is the angle, then what is 3 telling us? Fernando.
3 is the velocity of the Ferris wheel in feet per minute.
Almost. You don't get feet when you multiply, when you do 3t. What do you get?
Feet per second.
No, but 3t doesn't give you feet. 3t gives you what? Angle. So 3 is the speed of the wheel in radians per second. Right, it's how many radians the wheel goes every second. So that 3t would give you the total number of radians. Okay, cosine of 3t, specific quantity. Claim.
It's going to give you the x coordinate, which was the radius.
Okay, let's talk in terms of distance. How about which distance is it?
It's the distance to the right.
Horizontal distance to the right of vertical diameter in? What's our unit for that? Cosine 3t. Meters? Minutes? Radius lengths? Which one is it? It's the output of cosine. And radius lengths. Okay, doing good. What about 28? So the number 28, what does it mean in this situation? Farah? Is it the what? The point. A point isn't a value. So what? But the value 28 represents what? Radius. Okay, radius of the Ferris wheel. In what? In what? No, in what unit? What are we measuring? 28 is a measure of what? Meters. Okay, so it's a huge Ferris wheel, right? 28 meters is the radius. That's a huge Ferris wheel, okay? So 28 cosine 3t. Christopher Greco. Was there a question?
Yeah, for 3, you said that it's the speed of the wheel in radians per second.
Yeah. Minutes. Minutes. Thank you. Someone's paying attention. Yeah, let's think about that. So we got, I just said it was a huge Ferris wheel. What about going 3 radians in a second on a gigantic... All right, good. If you're laughing, that means you understand, because how far was 3 radians of rotation? Almost halfway, right? So yeah, if you were going in 1 second, if you were making it almost halfway in a gigantic Ferris wheel, this would be a thrill ride, not a casual ride, right? All right, good. All right, 28 cosine 3t. I think we were on Christopher. What is that quantity? What's that? You didn't get it? Okay, Michelle. Tell me about distance on this Ferris wheel. Horizontal distance. To the right. The vertical diameter. In meters now. Okay, so which of those is the input into the function? Edward, Morris. What's that?
The input would be T.
He wants just T. Is T the input? Absolutely, right? I lost the formula, sorry. Everything too big. There we go. Okay, so he said that the input is T, which is correct. Output of the function. Which of those expressions gives the output of the function? Keep going. Who was that again? Edward. What's the output? Which one was the output? The last one, right? That's the output. The output. See, the input is time, and the output of this function is how far to the right of the vertical diameter you are in meters. That's what this function does. Okay? What's the argument? What is the argument? Morgan. 3t is the argument. It's that expression that is our input into cosine. The whole expression that's the input. Okay? What's the period? Morgan, keep going. Did you figure out what the period was?
2 pi divided by 3.
So can you talk me through it?
Okay. So the standard period for cosine is 2 pi.
Good?
And since we're doing, since the input of the cosine equation is theta,
Yep.
we're saying that theta equals 3t.
Yep.
So
Yeah, you're doing great.
2 pi by 3t.
So we want to find the time so that theta gets to 2. You told me that what did you say? You said that the period of cosine is what? 2 pi. So we want to find when that angle 3t gets to 2 pi. Right? So we're looking for the t that corresponds to the angle becoming 2 pi. And that's 2 pi over 3. And so what is that? I think it's 2.09, is that right? What are the units and what does it mean? 2.09. Penny, what are the units on that and what does it mean? 2.09. Okay, well so what is it? It's the period or the amount of input, the interval of input to give us one full cycle. So if it's the input, what units will it be? 2.09 what? Nope, just minutes. It's time. It's the amount of time. 2.09 minutes. And what does it mean in this case? Yeah.
It takes 2.09 minutes to complete one cycle.
Yep. And so what would that mean for the Ferris wheel?
And that to go around one time takes 2.09.
Yeah, so that's about right. And these huge Ferris wheels, a couple minutes to get all the way around, right? Get all the way around. 2.09 minutes to get all the way around. So let's look at the graph here. So how do we see that period in the graph? So if I started here, tell me where to stop that would represent the period. Here. Okay, I'll do it again. Here we go. Right. And that's 2 right there. So a little bit more than 2. A little bit more than 2 is our 2.09. So this is one way to pull the period off a graph is called the peak-to-peak method. Peak to peak is the interval of input that gets one full cycle of output, and then when you get to that second peak, the cycle repeats, starts to repeat again. So that's one way to do it. So then also you could get it by what, low point to low point. Now if you use, this is called the midline. The midline of the function is like represents, in this case, represents what, our vertical diameter, right? Because we're going horizontally to the right and to the left. So this midline is like our vertical diameter. And so if we use the midline, you got to be careful, because if I'm going to start here, it's easy to say, oh, I'm going to go from here to here, and that's the period, right? That's only half the period. So you got to skip over the first time you get back to the midline and go to the second time. So from here to here is also showing the period of 2.09. So all three of those are showing one full cycle of output values. Here starting at the peak, here starting at the midline, here starting at the low point of the graph. Okay, does it make sense? All right, so now any questions? This next activity now is reversing it. I'm going to give you all the information about a water wheel, and you're going to write the functions, okay? Read carefully and think. Don't just throw numbers at answers, okay? Just don't take numbers and just start throwing them at answers. Think about it, okay? So, a water wheel makes a full rotation every 13 seconds. The radius of the wheel is 7.5 feet, and the bottom of the wheel is 2 feet above the surface of the water, okay? A point on the wheel starts at the 3 o'clock position and turns counterclockwise. Now, you've got 4 functions to write. You have to think about this. You can't just start grabbing numbers and thinking, that number goes there, and that number goes there, and there's my expression. It won't be right. Think about what you're reading and make sense from all that we've talked about in the last week. Okay, so you've got 4 functions to write: F, G, H, and J. Give it a shot. Go. Find the important parts of the... No. 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 There are no numbers in number 1. You don't need any of the numbers in number 1. That's it.
So what is this asking for? Okay, so it's T and so it's just
Takes the angle. It's the quiz, right? Really? It's the quiz. Takes the angle, gives you the vertical height radius. There you go. Above horizontal diameter. Above horizontal diameter. Trying to shift it. Still vertical height, but 2 still vertical height. 3 is a little harder. Number 2? No, it's still, you got the input wrong. No, so it's only going to be t, right? Yes, there you go. Do you know what you're looking at?
Yes.
Do you know what you're looking at? Input, angle swept counterclockwise from 3 o'clock. Output, vertical height above horizontal diameter radius length. That's the sine. So this. Now we want the same thing in feet. How do we get the same thing, vertical distance, but now in feet? So what is this? This is really the fraction of the radius, right? So the maximum radius length is 1 at the top. Every other sine is like a fraction of the radius. So to get feet, we're going to take that fraction of 7.5. Number 2. No, I just put number 2 up. It's still angle. It's not time. Input's still angle.
Well, yes, but
Yes, but what?
by multiplying the time by
But I'm saying that the input to your function g is angle, not time. And so you're making your input time. It's angle. Okay, so here's the deal with h. Now we want t, and it's going to be feet. So it's going to look like this. Some constant times t. And we got to figure out what that constant is. 13 seconds, a full rotation every 13 seconds. Therefore, I'm giving you the period, right? That's the period. So, is that 13 seconds? Is that a b value or a t value? Is that b or t? It's t. B is our unknown. So we're saying when 13 seconds go by, we want the angle to reach what? 2 pi, you see? See, the argument is bt. When time reaches 13, a full period, that's got to correspond to the angle reaching 2 pi. So then the value of b is? So we'll keep it exact. It'll be 2 pi over 13. Solving for b here. Talk through it again. So b times t is going to be our argument. You're given the period now, 13 seconds. So you're saying that when 13 seconds goes by, that angle argument has to reach 2 pi. So that this is 2 pi over 13 is the coefficient of t. So there's h of t. Any questions on 1 through 3? Question, Adam.
Can you explain our arguments more, please?
So the original form of this is going to be b times t. What does b times t represent? Okay, and what is the argument? What quantity is it? Angle, right? So bt is the angle. And so this is the period. So in this problem, I'm giving you the period. I'm saying that it makes a full rotation in 13 seconds. So that is an amount of time. So we're trying to figure out, this is our unknown. That's our unknown. So we're saying that when the time reaches 13 seconds, in order for it to be a full period, the argument, or b times t, has to reach the full period of sine, which is 2 pi. Is it better?
Okay.
And so b is 2 pi over 13. Other questions on there? Was another hand up. Does that help? Good? Okay, so this last one. So now this is vertical height above the horizontal diameter. Now we want to get vertical height from the water. So now we want to track the height of a point above the water. And it said that the bottom of the wheel is 2 feet above the surface of the water. So how am I going to write J? I can take the same thing I had before, right? That changes the radius of the wheel. So it's not that. We're going to add 2. So we got the vertical height, and one suggestion is to add 2. Let's just check that. How about? So some people are saying no, but let's just give it a shot. Y equals 7.5 sine of 2 pi divided by 13 x plus 2. Okay, so we're going to take that thing, we're going to move it up 2 feet. How'd we do? So imagine this is tracking the point's height above the water when the bottom of the wheel is 2 feet above the surface of the water. Correct? No, because this is showing that the point dips below the surface of the water. Do you see that? If it's the height above the water, then our x-axis is water. And so we expect this graph, the whole graph, to be up above, right? So what happened? We've got the water here. So we're going to draw a picture. So without adding anything, it's as if the wheel was, the horizontal diameter was at the water level, if we don't add anything. What we want is that wheel to be 2 feet above the water. The question is, how high do I have to move this? So when you shift a graph up and down, you got to think about shifting the midline. That's the way to think about shifting a graph up and down. How much do I have to shift the midline? So here's our new midline. The question is, how far is that shift up? So you can think of it in 2 steps. First, you're going to shift so the bottom of the wheel is at the water level. How much of a shift is that? That's 1 radius, right? So if I shift it up 1 radius, that puts the bottom of the wheel at the water level. But now we want it, what, 2 more feet up. So how much should I add? So when we were adding 2, if you were saying no, 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 that's good because you caught onto this. But imagine that it starts with the horizontal diameter at the water level. First, we got to get that bottom of the wheel to the water level. That's 1 radius, and now we want it 2 feet more. So that's 7.5 plus 9.5. And so you're imagining this is the water here, and this is that point circling around, and this graph is telling you how high above the water it is. So what's the max height? Oh, we got to go. So that's the point going up and down as time goes by. I'm going to add homework this afternoon. Due Monday. Yes, sir.